Hi, folks. I'm still waiting for my slides to upload. They just seem to be stuck. But, hold on. It says 15 seconds to go, but anyway, we'll see. Oh, now it's 20 seconds to go. I know TopHat was having trouble yesterday with some of their systems. We seem to be frozen, so I'll have to use Plan B, I think. Yep. Wait. Oh, it seems to be stuck. Oh, nope. Maybe not. It says it's ready to go. Okay. So let's try presenting slides. Get over here. Here's Dora. Okay. So I'm back in Halifax today. You can always tell by my background if I've got a bookcase over here. That's in Halifax. If it's all white and bright, then I'm at the cottage. And the main difference we've seen is it was so much sunshine when we were down there, and everything was just white. It just pretty as can be. Whereas here, when we were out for our walk this morning, it was the skies were starting to get light now, but it was very dark, very heavy gray, and you're starting to see the snow turn brown, with as it's melting and the roads and the like. In the countryside, they're not using all that salt, and even the roads look white. Oh, I got someone calling me. Hello. Hold on. I have to run and do something. Be right back. What's up, Dora? What's up? What's up? Quick. Need to pee? Come on, back to work. Yes, Dora's out having a pee. Hello. Yep. Oop, I'm back again. Where did it go? Oh, my slides just stopped. Let me start the presentation again. Let's present the slides again. Here we go. The challenge is working from home. Things are different. So let's get on the way. Okay, I promised you today we would start out talking about the assignment and what questions people might have. And that I don't know if you've got questions about it, start typing them into the chat now. And but I'll walk through the questions that I've received from students since the weekend. And as well, I had a Zoom meeting with the Mac Help Center, the students that are working there, and some of the other instructors. We had a Zoom meeting yesterday to see what questions are coming up. And this is a recap of what we talked about yesterday. And I'll just zip through those as we go. Okay. And if I don't hit your question along the way, I said type it in the chat. So first thing was, what do I want submitted? And because everything is digital now, there's no paper that we have to deal with, there's no problem in having a long submission. Take the original Word document that I've posted, and you insert your answers with each question. That way you're going to end up having a record that has the question and answer, question and answer, question and answer. So if for some reason you want to go back and review what you've got there, everything is there in one place. That get to that one then, Adam. No problem. So, but I want you to save it as a PDF because I've got it set up that TopHat will only accept PDF files. And so if you try sending me your whole spreadsheet, you're not going to be able to upload that. You have to only submit PDF documents. If you're emailing me and have questions, by all means, send me your whole spreadsheet. Makes it easier in many instances for me to figure out what your problem might be. Now, some of the questions, question 1, question 4, come to mind to some extent with question 8. I ask you to just comment on things or give me your opinion. And there are a lot of acceptable answers. I'm not looking for a right or wrong answer. The intent here is simply to make you think about what you're doing. Very frequently, we don't reflect enough. And if we reflected more about what we're doing, we'll understand it better. We'll learn an awful lot. But there are a lot of things that we don't reflect upon. That the other ones that you have in your assignment are very mechanical, and you'll find that in a lot of the future assignments. I'm just making you go through the mechanics of doing these things because I want you to be familiar with Excel, get more and more at ease with it. A lot of students are not at ease with Excel. I can understand that. It's technology that is not, it's not warm and fuzzy. It's not like social media apps and those sorts of things. There's a certain level of complexity to it. And you're not getting satisfaction necessarily out of using it like you would with if you're using other types of apps. But when you graduate and get into the workplace, Excel is it's a tool that you would use very, very frequently. And if you're not using it, you should ask yourself why, because so many activities you do should be, you should be looking at data that it leads to a lot better decisions or more efficient use of your time and efforts, whether you be in sales or in accounting or any other area. But I'll get to that later. But a lot of employers have critiqued graduates, and I'm not talking about St. Mary's graduate, I'm talking university graduates in general, don't have, those are essential skills they're looking for. So over the next few years in your program, you may not learn to love Excel, but learn to live with it. So anyway, so I'm asking you to take in the initial data, pull some stuff out, and paste it into a new sheet. And when you create a new sheet, it's going to call sheet 1. Don't leave it with the name sheet 1. Give it a new name. I said give it a name data, but you already have one called data. So maybe call it question 2 data or data 2, something like that. Similarly with a dictionary. Give it a name just to get you in the habit of every time you create a new sheet, give it a name. That there is, in the question, there is a table of that list of variables that I want you to use, and it has explanations. I want you to copy that table out of the assignment and put it into a new sheet. That's your dictionary, because that's the set of variables you're looking at. Okay, so some people don't know what it is I'm looking for there. Whoops. Okay. In question 3, some students are having trouble with VLOOKUP, and when they type the formula, it's not working. I'm still getting some of those. So that's happening here. So they've gone to use VLOOKUP. Now this is a different data file, different lookup. But if I looked at, I wanted to recode home, and I would go and I'd insert a column, and then I'd go to type in a formula to convert the values of home into these numbers, like a 7, into words. The problem cases I've encountered so far have been ones where up in this box, up above, it says, instead of general, it said text. Okay? little thing. They typed in VLOOKUP. Okay, it is. And I'm going to take the value in column E2. I've got a lookup table over here, and it's got a table home. Looks like that. And I lock the table by using F4, putting dollar signs around things. The new values in column 2, and I want false. Now, some of the people that have had trouble, they've made typos like me, and they've messed it up because of typographical things. They've missed a comma, or they put a period instead of a comma. They grabbed something incorrectly. They went to the wrong sheet. Instead of the lookup table, they pulled a different sheet. Now, if I press enter, you'll see it's just got text in here that do wrap, so you can see the text that it's got there. And that's because I told, well, it thinks it's got text in this column. So sometimes this works and sometimes it doesn't. If I change it to general, yeah, it's still not working. I'll have to go delete every thing in the column, give myself a new one, make sure it's called general, type it in properly, and it should work now. I have my table, lock it. I want the second column, and I want false. And it works. So the problem had to do with this particular thing up here. Okay. Whoops. What am I doing here? Our slides. Question 4. Again, it's a reflective one. When you did this survey, when I asked you what year did you start, I gave you a list of options. You could have started in 2021, right now, this term is your first term, 2020, 2019, and maybe 2018 and before. So you had very little choices to put them in. When we did the survey a year ago, we allowed students to put in a number. So they could have put in 2020 or 2018, or they could have made typing errors and put in 218 instead of 2018, just drop the 0, or 208 or 2008. They could have made all kinds of typing errors. And so, but they gave me a number. So last year they gave me a number. This year you're giving me a category. Last year it was interval data. That year is an interval data. It's not ratio data. You can't take the ratio of 2 years. Whereas this year it's ordinal data. You have choices, categories, but they're in an order. So there are good reasons why you could use either one. And what I'd like you to do is just comment on that choice, because when you're at the very beginning of doing your data understanding, data preparation, and collecting your data, you have choices about how you collect it and how you're going to define those variables. And after the fact, it's difficult to go backwards and flip it. So I just want you to think about that as a choice. There isn't a right choice to this one. Both would be acceptable, but they both have limitations. Question 5, that students, I've had some problems with custom sort, and I'm not sure exactly where the issue is. Some say it has to do with a Mac. Some may think it's Office 365. I don't have a Mac, so I can't check that. I did try using the web version of Office 365, and I didn't have any problems. But students have shown me screenshots, and where it says custom sort or sort by color, it's ghosted out. They can see the option, but they can't click on it. And I don't know what the problem is that they've got. Um, I was told yesterday, I didn't realize this because I don't use Office 365, but you don't have to use the web version. You can install it on your PC. And I'm told that when you go to that options to do with Office 365, one of the options is to install, and it's supposed to be at the top of that page. So if you want the full version, and that I'm using the full version, the screenshots look different. It looks different with the web version than the full one, but I'm told you can install the full one. That some of the questions I asked you to look at different things, like counting the number of students outside of Canada. And one student noted that one of the variables I've got is live now, and that's where do you live right now? Are you in Halifax right now? Are you outside Canada? Are you elsewhere in Canada? But under the home variable, it's where your home is your home outside Canada? And that was what I was looking for. That in question 6 and question 7, and this goes to Adam's question about looking at students in 2020 or those in 2021, if you're counting people or finding averages for one variable, but I want you to look at only one subgroup, you're going to have to go up and filter on the survey. Are they in the 2020 survey or the 2021 survey? So go up and filter on that box and then see what your answer is in the total row. And with question 7, with C, I'm asking about how many hours a week you spend doing recreational activities. And I was asked, well, in 7B, we filtered on the number of hours studying to be between 5 and 50. Do we want that filter to remain in 7C? I hadn't planned on it. I'll probably accept that as an answer. It shouldn't change that much. In question 6, I did ask that you remove the filter each time you do a question. I should have said the same in 7C to remove filters as you go. And finally, in question 8, we're getting a variety of problems. One of them has to do with Office 365, which doesn't have the data analysis toolkit, at least in the web version. So what do you do? If you are using the web version of 365, and I went through and did this, then you go to there's an insert tab with add-ins. The explanation's here. Let me see if I can find, hold on. Hopefully I don't get myself messed up here. Is this the web version? It's going to give me a screen so you can see this. If I go over here to insert, there is a thing called add-ins. And if you're clicking on store, because there's no ones over here, there's a category called data analytics. And there's a bunch of these ones down here. And there it is. There's one that's called XLMiner Analysis Toolpack. Click that one, put it in. It will give you functions that are very similar to what we have in the desktop version of Excel. Let me get back to my class. Where are we? I got too many things open here. I can't find me. I think I'm here. Yep, there I am. And my slides. The other thing that, so that will do it. We'll need to use that analysis toolpack with future assignments. So you'll need to download that XLMiner one. XLMiner is a commercial product you usually have to pay for. This analysis toolpack is just a very limited set of what is in XLMiner. And it's free. You don't have to pay for it. The other is that I seen students, and it happened last term. They did the histogram properly. They had their bins in 1,000, 2,000, 3,000, 4,000, and everything laid out just the way it should be. But the output they got from Excel went and changed all the pins to strange numbers. I've yet to find out what the cause is. I've been able to replicate the error. I've been able to make the same mistake happening on that student sheet. It's working fine in my sheet, not working fine in the student sheet, and I don't know why. Can't figure out why it's changing everything. If you are encountering that, just submit what you have. I'll tell the markers. I've already told them. We're going to have sort of alternate solutions to reflect that, and I'll update the marking key for them to reflect that. Don't worry about it. And that's the extent of questions I've seen so far. So is there any more questions that jump to mind? Nobody's typing. Nobody gave me any others. The assignment should be manageable. If you are getting stuck, frustrated, angry with the assignment, then you should be emailing me and asking for help, or the Math Help Center asking for help. That it shouldn't be happening to you. I don't want you to get stressed out doing an assignment. It should, if I wrote it properly, should be straightforward. What I want to do today is move into more interesting stuff where we're looking at comparisons, looking at relationships between variables, not looking at just one variable at a time. And that's what we did last time. We looked at where's the middle, what's big, what's small, some of those sorts of things. And so we looked at percentiles and quartiles. Looking at a single variable, it helps us understand what are outliers and how the data is spread out and the like. But it doesn't tell me about patterns. We started to look at some of those in a crude fashion, like you're doing in your assignment, where if you were looking at studying patterns, and this was shocking to me. It was discouraging last year when I looked at how many hours a week students spent studying, and they said it was only 12 or 13 hours. How much time? About 2 hours for each course you're taking, maybe 3 hours. Not an awful lot. Whereas this year, students are saying it's more like 22 or 23 hours a week studying. So they're spending 4 or 5 hours for each course doing studying in addition to lecture time. A huge change. Asking my students last semester about their experience, what they found was different. And they found that the workload, and including their studying time, was huge compared to what they had seen previously. And these were, most of them returning students. These weren't brand new students starting in. And they were shocked by the workload that they had to do. It was much more than they expected and what they had done previously. And it seems to be this working in an online environment. So we found that pattern, but we had to do a lot of work to do it. But it's patterns and changes and those types of things that very often give us insights and alert us to things that we may not have recognized before. And just to show you, I'm a data nut. I'd love to have a bowl full of data each morning for my breakfast. I live on data. And so each morning I subscribe to a variety of different sources of things and may look at it more. And this morning before my 8:30 class, and I had to rush through this stuff quickly, I got one of the blogs. It gets posted at 8 o'clock each morning if they're on time. And this one talked about data, educational data. And I'll just show it to you on my screen here. That it's hard to get Canadian data on education. Institutions don't publicize a lot of their data. They're very secretive. They hide everything. And most provincial governments are very bad at collecting data and worse at reporting it. With Atlantic Canada, we're actually quite good. The Maritimes are. And Ontario, with application data, it's readily available. They don't promote it, but if you know where to look, you can find it. And in Ontario, all students have to apply into a common application center. So regardless of whether you're applying to University of Toronto or to McMaster or Carleton, your application goes into a central repository. And when you apply, you list your top 3 schools you'd like to apply to and rank them first, second, third. And every month, the center that collects this publicizes application data, summary data, by program of study and by institution. And they, this year and last year, and if you collect it all, you can come up with some neat graphs. Now, this graph was by it's an organization that took the last 15 years and created a graph. And it's interesting to see. This is over time. The gray is the number of applications into STEM subjects, science, engineering, computing science, that type of thing. And as you see, it's steadily been going up. Whereas arts programs have been going down. But the last few years, everything has been relatively flat. This last year, between 2020 and 2021, big uptick for a year-to-year change in STEM subjects, a big drop in arts. This is a drop of 3,000 or 4,000 applications into arts programs as their first choice program. Business, no change to speak of. Health related programs, it's going up, and other types of programs, it's going down. So science, technology, health, big upswing in applications. If you are an institution heavily dependent upon art students, you've got a problem come September because students don't want arts. And this is a big drop. This would be a lot of empty seats, big capacity change. Okay, but maybe they'll balance out. The other thing that was summarized is the year-to-year changes in applications to institutions. And this is shocking. McMaster is a very large institution. They probably have 20,000 or more undergraduate students. So if their applications went up 5%, that's another 1,000 students coming in. That's a lot of seats, more residence rooms, a whole bunch of different things. They're up 18%. That's a huge. We'd never see changes that big at a big institution like that. That's absolutely crazy. Waterloo, well, science, technology. McMaster, science, technology, and health are really big there. Toronto, some big increases. But at the other extreme, Brock, which is Brock down in St. Catharines, near Niagara Falls area, that sort of thing, they've probably got 12,000 undergraduate students. They're seeing a drop of almost 15%. And so if you combine, if you're in charge of the Faculty of Arts at Brock, they're probably looking at just a major crisis on their hands for September. If you were in the sciences and engineering, computer science, and master, you've got to decide, do you take in all these extra students or do you just be more selective than you already are? Big changes. Looking at, if this was a business, different programs or different products, these are different retailers, if you can imagine, selling the different products. There's looks like a big swing in product mix and big swings in terms of who are winners and losers in terms of customers. Businesses need to be tracking this type of stuff, and with industry data and sales data, they would be doing this type of thing on a regular basis. And all of these are comparisons. We're looking at changes over time, and we're looking at one product category versus another product category and how the swings are. We're looking at ourselves versus our competition. So all of these are looking at data, but looking at comparisons. So how do we do this quickly, easily, effectively? And you'll notice with this, I've been showing you just graphs to show it. We're going to start with looking at numbers. We're going to end today looking at graphs because they're a very powerful way of communicating patterns that we've got. It's maybe a going off topic, but I find this stuff fascinating. But that's me. As I said, I'd eat a bowl of these for breakfast. We're going to be using a tool called a pivot table, and later at the end of class using a thing called a pivot chart. It's the most powerful data analysis tool that there is in Excel. It's really attractive to use. If you hear about data visualization or dashboards or some of these types of things, this type of application of a pivot table or a pivot chart is very common in software that's designed to explore relationships quickly and easily. The tools we were using last time, that total row, one plus thing, or histograms and descriptive stats, are very, very limiting. The analysis toolkit in Excel is very, very weak. It's not a very good tool to be using. We'll use it a lot later because we don't have a choice. But if I'm just summarizing basic patterns, a pivot table is a far better tool. It's one very few university graduates, again, getting back to what employers have told me over the years and what graduates have told me, that it's not just that students have weak Excel skills or basic skills in looking at data. None of them know anything about pivot tables. And those that do are highly regarded within organizations, that they are, they may think of them as being the geeks. These aren't complicated tools, but it seems students aren't taught about them. And this is one of the big takeaways of tools in this course. What should you know for the future? You may not use it in your courses, but in the workplace, if you're using data, pivot table is something you should know. So I can go through in slides of how to put it together, but I think I'm going to just show you with data. So I'm in a table of data. I'm in any cell, and if I go up to insert, this is where we created a table, and you'll notice it's now ghosted here because I have a table. It's so I can't click it a second time, but it has one called pivot table here. Click on it. Comes up. It says select a table or a range of data, so a block of data. If your data isn't in a table, it will generally, like when we built our first table, it'll guess as to how the data is configured. That, like in a table, it needs unique columns. So if you're not in a table right now, every column should have a name to it. And generally put it in a new worksheet. Okay, don't clutter up your data sheet. So I get this. What's this thing telling me? Here, it's got a whole bunch over here that we'll fill in a moment. But the first thing to look at is this group over here on the right. It says pivot table fields. What is a field? A field? Where horses or cows are? No. A field is a computing science term used to really describe a column. It describes a variable. Computer science people call variables fields. So we've got ID, the year you started, program that I created a column a little while ago. It's thrown in there, home, a bunch of other things here. Okay. And that, this isn't a good one to use. Let me just switch here. This is using this table, I think, which has got a lot of clutter in it. I've got another one here that's better. Let me use this one here where I've got more words in it. So I'm going to insert another pivot table. Okay. And, I should give it a name. Where did I put it in a new sheet called sheet 1. I'm going to rename that. so I know what it is. Always get in the habit of renaming any new sheet you create. So here I've got, use the same one I had a minute ago. Excuse me. Let me delete this. Yes, I want to delete that. And where was the other one that it did? I think. Yeah, let me get rid of this guy. Oh, this is the guy. This is the right one. Yeah, sorry. Here's my right one. Okay. So it's got program, program 2, home, home 2. These are all my different variables I've got. Okay. And the different things I can choose from. The table has got columns, it's got rows. So I can put my different variables into the columns. I can put them into the rows. And then the table should summarize something. How many I've gotten different things, what their salaries look like, some of those sorts of things. So let's suppose I wanted to look at, well, I should check to make sure I do the same thing as my slides. So there's different things I can do here. I'm going to look at programs, and I'm going to look at gender. Okay? And so I'm going to have rows being what program you're in, columns, what your gender is, and I'm going to summarize your salary expectations. Don't worry about these numbers. So let's do that. So all I do is I drag and drop it. Drag program down here to rows. So make this bigger so we can see what I've got. Okay, so I've got arts, business. This is the wrong data. How did I get that? Anyway, live with this, okay? It's coded differently, I'm sorry, than what I've got in the slides. I must have more than one spreadsheet here. Let's see if I got it in this one. Excuse me. Maybe I've got too many versions of the spreadsheet in my computer. So I've got program I'm going to put here, and excuse me, I've got to take a whole bunch of filters off so that this looks plain vanilla. Okay, there we've got the different programs that, and I'm going to want to look at gender in my column. So I swing down here to gender, and I put it as columns. And again, I'll fix that in a minute. So it's got, these are the different options here for program, different options here for gender. I want to look at salary. Where is salary? There it is. And it's given me the sum of salary. See, when I put values down in here, it's very tiny print for you to see on my screen, but it says in the values box, sum of salary. It's going to summarize the variable I put here, the field that I put there. But you can summarize things in many, many different ways. Click on it. It gives me a list here. That the last item in the list says value field settings. You're going to be clicking on this very frequently in a pivot table because you're going to want to change the formatting many times over. So I'm going to start it. I'm going to click on this, and it gives me summarize value field by in boldface here. And the sum, count, average. So if I hit count, it would tell me I've got 752 students gave me a salary figure. And here's how they broke down, how many in each group. Okay, but I don't want that. I want to know the averages. So go back, go down to the next choice, and that's average. Okay. Yuck. It's given me these numbers. Here's 56,328.048. I don't want all that. These are dollars. Go back here. So I've got the right summary, but I don't like the format. So I can go down here to number format. This is general. I want currency. These are dollars. And I don't need decimals. I'll make that 0 decimals. Okay. So that's a little easier to read. I wish I could get it to round it off to the nearest thousand. Something, because it's still too busy, too much detail for me. But it's getting easier to read. And hopefully you've picked up, like at the very beginning, making a data file easier to read. We changed headings. We've changed the way values are coded. That all the time trying to make this, because when we're processing this it by looking at it. We're not machines. Okay? And so we need to make it attractive for us to look at. When I look at this, I've got junk, invalid, not applicable, blank, gender. That keep your table tidy, clean. That if it's messy, then your understanding is going to be messy. So let's go up here. There's a down arrow beside row labels. Click it. Here's a list of the different rows. I don't want this one, and I don't want that one. So I'm unchecking them. They're gone. Column labels. Down arrow. Click on it. I don't want blanks. There. Better. Okay. Now I can start looking at it and seeing, all right, art students expect to earn less than business students who expect to earn less than science students. Okay. That I've seen this before. We saw that looking at total rows when we were exploring that previous classes. And if I then look at art students, males seem to earn more than females. And business males earn slightly more than females. At least they expect to earn. But here in science, it's the reverse. Female students expect to earn a lot more than male students. Okay. But if you recall, when we looked at the salary data, there were outliers. There were some numbers that were extremely big, some that were extremely small. This didn't make sense. Let's clear out the garbage again. So what I want to do, that's one of the boxes I have here, is filters. So take salary again and put it in the filter box. All right. Oh dear. Looks like I've already got some filters on here. Oh, changes my numbers, excuse me. So I used this before this class, and so a lot of the stuff I did from the previous class is still here. So when I drag it up into this box, salary over, it pops up above my pivot table. And so if I've got something up here, it's something that I can filter on. So I want to filter on salary. I click the down arrow. It's not a great filter. In your assignment, you could go and do a filter between 20,000 and 120,000. Here I can't do that. Not quickly and easily. I can only do it by unchecking things. So I'm going to do it the hard way. I'm going to uncheck all the numbers I don't want. Okay. And I'm actually going to do it more like it's not the way I did it in the slides. I only went up to 10,000 here. So I've kept some of the numbers that are really low, but not crazy low, like the zeros. If I click OK, it changes things around a lot. There must have been some female students, and there were female students, I think, in engineering that gave crazy numbers for expected earnings. Probably a typo. Once those were taken out, we now see that males expect to earn $5,000 more than females in arts, and about $5,000 more in business, and about $7,000 more in science. That there appears to be a huge gender difference across programs. So we're seeing business students expect to earn more than art students, science students expect to earn more than business students, but also there's a big difference by gender. That's an important pattern that you may then want to start exploring. That the arts versus business difference isn't surprising. That I think many students in arts realize that their employment outcomes are somewhat more limited in some respects than in business. They're not that limited, they actually do okay. But particularly starting out, they have lower expectations, and that's not, there is data to support that. The actual salary data for science, though, isn't as great. Although STEM subjects, like I just showed you before, are going through the roof, engineers earn a lot, but biology majors don't. Chemistry majors don't. Same with others, unless they go on to do graduate degrees. If you just got a Bachelor of Science in biology, you don't earn any more than a Bachelor of Arts in sociology. That you need to have advanced degrees in science to get into the big paying jobs. But the hype around STEM has convinced many people that science pays big bucks. It doesn't generally. Anyway, so this is neat. I can pull all this stuff out. We were looking at some of these sorts of patterns before by looking one by one by one, looking, filtering, and looking at changes in the total row. But now I've got it all here in one place. This is really, really powerful to do. And I can do all kinds of different things. I can swap variables in and out, change filters, change summaries. This is very quick and easy. You don't have to be a rocket scientist to do this stuff. Now, we've done this, we did that, we did that, and did that, and with the filtering here, I went 20 to 120,000. And if you look at it, if I take out those students that, and there are quite a few, expect to earn between 10 and 20,000, it really pulls down the female average earnings by having that in there. There becomes a bigger gap here. And this gap gets slightly larger as well. It tends to be among women that are expecting to earn these crazy low salaries. But, and okay, here's something we should look at. And let me get back to my spreadsheet here. Let me make this the same as my slides. Oops, excuse me. See all of these different values. There's actually a lot of people that pick those numbers like 15, 17, 18,000. So here's what I just had in the slide. Okay. Now, are there a lot of students in these groups? Last class, at the very end with descriptive statistics, I introduced the idea of standard error. And the purpose of introducing that was to remind you all of these are estimates. If I took another sample of 800 students and summarized the results, I'll get different numbers. Similar numbers, but different. Are they a lot different? Standard error would tell me on how big a difference I might expect to see in these averages. And I think last time we thought a standard error was, at least for the grand total, was around $1,600. So don't be surprised if my numbers here are off by about $1,000, $2,000, $3,000. So this might not be 50,000, maybe it should be 53, maybe it should be 47, somewhere in that range. Okay? And so these differences I see here, are they real? You know, this difference here of about $2,000, is that real? This difference here in science of about $6,000, is that real? Depends upon our sample size. If I've got large sample sizes, differences are real. If I got small sample sizes, probably not. So how many values have I got here? Take one of the variables. I usually use ID because everybody's got an ID. There's no blanks there. Put it down here. Let's say sum. I don't want the sum. Go to count. Get in the habit of doing this when you're looking at patterns. Now, you'll see here, whoops, that, okay, doesn't want to do things for me. That business students, I've got quite a few males, 107 males, 119 females. In art, I got lots of females, reasonable sample size. Not as many as I'd like among the males. And in science, my numbers are a little bit on the low side. They aren't too low. Generally, if I'm above 50 or 100, it's not too bad. If I'm getting down to 20 or 10, then I get worried. I don't like little samples like that. You'll see a lot more about this in a stats course where they talk a lot about small samples. In general, I don't like small samples at all. Most of the time, there's no reason we should be dealing with tiny samples. But sometimes it happens, and we should be more cautious. The smaller the sample, the more cautious you should be about the numbers. So I should be more cautious about these science numbers than I am about the business numbers. So in business, there's a difference here of about 4,000. Okay. It's enough to tell me males are definitely going to earn more than females. But this one in science, because the samples are somewhat smaller, well, it's a bigger difference of about 6,000, so it probably is real, and I'm not too concerned. I'm not so sure about the difference in arts, given my sample sizes. It may be if I took a different sample, the numbers would change somewhat, and there may not be a big difference between males and females. I'm not sure. If you've got small samples, and I'm just going to artificially create them at the moment, let me just click these funny guys, the invalid and the not applicable. And you'll see that in the invalid, I've got some very small numbers, particularly for men. And not applicable, those are blanks. You know, I wouldn't compare this 55 and the 33 because this is only based upon 3 students. This is based upon 5 students. I get suspicious of averages that end with zeros. I only get that if I've got very small samples. That once I get into larger samples, averages, I get all kinds of funny numbers at the end. So what can I do to deal with that? What I could do is at least take the blanks and the invalid, the strange ones, and group them together. So click on invalid, hold the control key on your keyboard, and click not applicable. Oh, didn't. There we go. So I've got both of them lit. And so I've selected both of these. Now they're not together, that's why I pressed the control key to click both. And now right click. Why did it do that to me? Excuse me. Now it's doing all kinds of stuff. Let me get rid of this sheet so it doesn't jump over here. Okay, now I had, where was the sheet I was just looking at? Oh, this is a different spreadsheet. Yeah. Let me close the spreadsheet altogether. I think this is one I don't want. This is something that Excel does to me sometimes too. Yeah, this is a spreadsheet I don't want to work with right now. And no, I'm not going to save it. I don't know what I did. So I've got these two. Watch it. If you've got multiple spreadsheets open, sometimes with Excel, when you go to do certain functions, it flips you to the other sheet. Why? I don't know. If I right click, I get a list of different things I can do. And one of them is called group. So click on group. Whoops. Excuse me. Click on group. Okay. Excuse me. It goes back again. Excuse me. And it's doing things from my 8:30 class. Normally when I hit group, this is what I should get as my pattern. It takes the invalid and not applicable and forms a group and calls it group one. It also takes the ones I didn't select, arts, and makes it its own group, business its own group, science its own group. With each of the groups, it has minus signs by it. Click on those to collapse. Minus, 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 minus. When you're doing grouping, I recommend you always collapse the groups. That was what you were trying to do. So you're trying to hide detail and combine things. So collapse it. Use the minus sign. Group, you can change the name. I could call this now other or anything else you want. And that's, I've now got it as a merged thing. And so this squishes these. The sample sizes are still small. I've still only got 19 here. It's better, not perfect. And interestingly, in this other group of strange things, the gap between males and females is even bigger. But the 60,000 may be suspect because it's based on only 19 values. And so it's probably not precise. It may well be off by $5,000 or more. But still, it's interesting that females are still reporting average expectations much lower than males. Where I am here. But you'll be looking at this much more in a stats course and looking at precision. I'm not going to focus on it in detail in this course, but it is something that we still have to always be thinking about in the course. Okay, so I did my grouping, and I fixed that up, and gave it a new name, and this is what I just showed you. I think the numbers look a little different. Now let's look at a different one, and I'm going to mess things up. I'm going to take, before I do, notice over here, this was program. I've got a new thing in here called program 3. This is my grouped variable. It's called program 3. So don't be surprised if you get new things being created along the way. Let me take these out. Okay. And something I like to do comparisons on in students is look at patterns by socioeconomic background. That often those are big indicators of student behavior. And parental education is the best indicator of of socioeconomic background. So I drag that down. And excuse me, I've got some things hidden here. So there are all kinds of different answers students can give on these sorts of things. That if you don't think this is an important variable, we did a survey, or at least I was involved in it with the Maritime Provinces Higher Education Commission a number of years back of grade 12 students in New Brunswick, Nova Scotia, and PEI, and a massive survey about their expectations, what they planned on doing after finishing high school. And we did ask about parental education, that among students whose parents had a university degree, at least one of them had gone to university, the vast majority, it was like 80% of those grade 12 students planned on going on to university. Overwhelming percentage. A small number thought of going to community college, and some thought of going into the workforce. Among those students whose parents had high school education or less, that it was probably about 30% thought of going to university. There was about 50% thought of going to community college, and about 20% going directly into the workforce. So their plans were very much driven by what their parents had done. And parents exert this huge influence on students. Whether you think, no, I'm going to be different from my parents, are an awful lot alike. But it gives us a lot of clues about changing from your from low income to middle income and that type of thing, shifting. Education is a good indicator, and it is a great leveler in terms of movement around socioeconomic class. So that's why I look at it. When I'm looking at my data here, it's hard to process this. I've got very tiny samples in, I don't want the don't know, unsure. Let me get them out of here. So I'm trying to get rid of distractions. Okay. Still, I've got a lot of different categories here, and some of them are very small. A doctorate, a PhD, very few students had parents with doctorates. A fairly small number had parents that had a professional. That would be a law degree or a medical degree, that type of thing. And some had master's degree, but still not huge numbers. So what I could do is try just combining these ones, okay, and do it the same way I just did. So like, we click on these different categories, and I'm going to group them. Okay, and again, this is from this morning. And I've still got funny things here. Okay, so it's given me a group for high school, college, bachelor's. Oh, excuse me. Anyway, I shouldn't have used the same file I used this morning. I should have pulled up a new one. I can collapse this one, this one, this one, and I'm going to rename this one. I'm just going to type in a new name. I'll call it graduate degrees. You'll notice the sort order of these, and this is where I'm getting messed up because of this morning. It won't let me sort them. Can I do it this way? Nope. These should be in alphabetical order, but you'll see that they're not in that order. Let me pick a different variable then. Can I find one to put in here? Let me try something else. I can't restore my original data set here, so I'm going to pick something else to play with. I'm going to go and look at, because again, I got small samples. Okay, so I'm going to pick some of these ones and I'm going to group them differently. So this isn't what's in my slides. I'm going to pick these ones from outside of the Atlantic region. Okay, and I'm going to hit group, and I'm going to call this group West. And I'm also going to pick Brunswick, Newfoundland, PEI, and I'm going to group them, grouped and grouped, and I'll call that Atlantic. And collapse it. And then I've got Nova Scotia. They're not applicable. I'm going to get rid of. Okay. And outside of Canada. And suppose I wanted to go and look at the patterns as I move east to west among things. So the first group I'd like to be at the top of my list. These ones are sorted in a particular fashion. I can right click this and I can move it. I'm going to move it up to the beginning. I'd like Nova Scotia to be my first group. The next group are the ones that are nearby. I'd like to move it up one. And then I've got Western Canada, and then I've got outside of Canada. So I can move my labels around in this sort of fashion here. And if that's the way I want to do my sorts of comparisons. With the parental education one that I was trying to do before, I'd already done the movement in the previous class. Sorry, parent 3. Oh, okay. Why isn't there? It is. Parent education. And these different ones here. Okay, and these ones. Oh, this one isn't sorted. Good. Okay. So last time I went and collapsed things. I took doctorate, master's, professional. I did a group. I called this one graduate. And you'll notice this one has been sequenced. I did this in the previous class. I sequenced it from, this is an ordinal variable now. Education, this is the lowest level. Middle is community college. A little bit higher is bachelor's degree, and then higher again is having a degree beyond a bachelor's degree. And so if I was looking as education level increased, do salary expectations increase as well? My samples are reasonably large, so I'm going to get rid of this detail, and I can look to see what patterns I have. And you'll find it does seem to be going up, but it's a very, very weak pattern. There doesn't seem to be a lot of change one to the next. And it's the same way with males and females, that they bounce, in fact, up and down. So college is low and high school is higher. High school is better than a bachelor's degree. Is that really the case? I don't know. It's these are their expectations based upon their parents' education, not the students' education. But they're bouncing all over the place. I've got a margin of error probably of a couple $1,000s. So when I'm looking at this by parental education, I see no pattern whatsoever. So students that have chosen to go on to university, their salary expectations are not being influenced by their parental education levels. Those that came from potentially more wealthy families really aren't expecting to earn more than those that may have come from lower income families. Okay. So again, it's interesting stuff that we may be able to pull out of our table. Where are my slides? Am I on track here? So here's what I did. It's not easy to read with all the frequencies, so I should take them out. But I've sequenced. This is what this is alphabetical order, would be this way. And so I'd want to move high school up, college up, because it's an ordinal variable. Put it in a fashion that makes sense. And so these were all the moves, and this is the table I just had a minute ago. So it's telling me that no, parental education isn't driving their expectations, which is a positive thing. Because if you're going to shift your socioeconomic group, you don't want that to be happening here. This is different in the US. There is a big difference. The people that come from high income families expect to earn more, and in fact, in many instances, do earn more. That's a complicated story behind it all. So be careful though. These are just estimates, but we can do all kinds of different types of this what if, flipping things around. Watch out along the way because I'm doing filtering even though I don't know it. I'm in some of the boxes, like on gender, I'm hiding the blanks. I'm actually filtering it. And in my fields list, we're going to find it's got little funnels along the way of things that I filtered. And it's helpful sometimes to look at that. It doesn't tell me everything that I've hidden, but it does tell me some of those. And we're hiding things for good reason to make it easier to understand. But watch that you're not hiding important information. So I'm going to do one last example, and this is one where I'm going to look at when did you start your program. So one of the variables that I've got with this data set is the year you started, and it's in your survey, it's the year the student started. So in this instance, they went back to 2002 up to 2009. That students that started in 2009 were first year students because this survey was done in March of 2010. So they're in their first year. And these are second year, third year, fourth year, and people that further back. So let's clean this up a little bit, in part because sample sizes are small in these early years. These are students that are over time, in a sense. They're in a 4-year degree program that they should have finished by now, ideally, if they had been completing 5 courses every term. So let's group these. And I'm going to collapse it. I'm going to call it before 2005. Okay, it's a label. And it's sort of busy. It's maybe hard to see patterns in here. Maybe you see it, but there's a lot here. And most of us are visual learners. If you look back to the first thing I gave you when looking at patterns, they were graphs. We just looked at charts. So let's look at a chart. If I'm in the Analyze tab, I can get what's called a pivot chart. Okay. And it gives me choices. The default is a column chart, and they call it a clustered column chart because it's clusters of columns. And click OK. Okay. You get this out of the way. I don't really need it. So here's my chart. Make my screen a little smaller so you can see my chart and my table at the same time. And with this, just glancing at it, I can quickly see that females earn less than males, or expect to earn less than males. Every group of students exhibited that. Difference isn't huge, but I can see the blue column is smaller than the orange one. And if I look at the columns over time, they're trending upwards. The first year students have higher expectations of what they're going to earn than those students that are about to graduate and have probably already started their job search. This is March of their final year. So they know what the marketplace is paying because of the jobs they're applying to. So I can see this pattern very, very quickly from just this one picture. I'm looking at a pattern. I'm not looking at numbers. I'm not even paying attention to the scale on the left. I don't care if this is 47 versus 50. I'm just care about, well, it's this blue column is shorter than the orange column. When looking at patterns, pictures are far better than tables. If you have to drill down and know specifically what they expect to earn, I need the table. But looking for patterns, I can just look at the picture. And I can do all kinds of crazy things at the same time. Let me go back here and bring back my field list. If I flip this out, if you wanted to look at program, whoops, excuse me, get rid of this. There we go. Here's one we had before on arts, business, science. Oh, there are these ones I don't really want. I can get rid of them right on my chart. I click on this program thing, and I don't want this guy, and I don't want this one. There we go. Art students expect to earn less than business, expect to earn less than science, and once again, females expect to earn less than males. I can see all of this really quickly just in a picture. I don't need a table of numbers. I don't need all these digits, the 47,179 versus 49,690. I don't need that detail. I can see it here. We're going to leave it here for today, but in the next class, we're going to start. Let me just do a quick recap, I guess. Here's what I did with my slides. So anything I change in the chart, or in the table, gets reflected in the chart, and I can even do some of the changes in the chart, and they can be reflected back into the table. I can do all kinds of swapping and exploration. That charts are a really powerful way of doing it. So what we've done today is just build that basic pivot table, and this may seem straightforward. Go and try doing it yourself. You can do it with your assignment, for that matter. And start exploring things, looking for patterns that you've got. Look at those questions in the assignment where we compared the 2020 students to the 2021 students, and you can look at pictures of that by creating a pivot table and a pivot chart. And we can filter, we can hide stuff. That my cautions are mainly about sample size. Don't read too much into it. These are only estimates. So small differences may not be real. They may just be because of our sample. If we got a different data set, that difference might disappear. And when you're looking at too many groups, you're taking a data set and splitting it up into many little boxes. So I may be taking 600 observations and putting them into 6 boxes. That means on average there's only 100 in each box. If I ended up with splitting it up so that I had, 5 columns and 6 rows, I'd have 30 boxes. So at 600 values, that leaves me only 20 in each box. The sample sizes get very, very small very quickly. So be cautious about that. And watch out about having hidden stuff. That you hid it to do one thing, that filter may still be in place when you're doing other things. Go back and check on that. As you've seen today, the stuff I did in the 830 class is still being carried forward into this one because I haven't gone and reset things like clearing filters. So next time, I'm going to show you how you can use pivot tables and pivot charts to do a histogram. A far better job than with the histogram function. And we're going to look at categorical variables. We're going to look at counting how many are this type or that type, or what percentage are. It should be just as easy as looking at averages, but it does present us with new challenges in interpretation when looking at count data instead of average data. You have to think about it differently. And we're going to use charts all the way along. So every time we do something in a table, we're going to be seeing the pictures and making sure that the picture is what we think it is. Because you can get into some deceptive pictures when looking at counting data instead of this number type data. Anyway, I've gone too long. We're done. Good luck on the assignment. You've done well in all the tests, and quizzes, that sort of thing, so I'm expecting good things from you. But if you run into problems, send me an email. Try to get that resolved. My job is not to make you stressed. It's to help you understand this stuff and do it better. Take care. You have a good weekend too. Bye-bye.